Well, what we're working on now is this guy, right? And then quiz tomorrow, so keep that in mind. So what we're going to start with is, and I do have you do one of these. Yeah. Oh, I'm not sharing, am I?
Are you supposed to be sharing your screen right now?
I am, Jake. Thank you. Let me get that up. What's that? You found the problem? Yeah. Okay. All right, should be popping up. So those of you who are home didn't hear it. Here's your quiz review. So if you wanted to print it, it's on your Canvas page, 4142 quiz review, and it should look like this. All right. Can you guys see my screen right now? It's just spinning for me. No, they can. Okay, good. So here's our graph. We want to write the piecewise function for this. So it says using the piecewise graph to the right, identify and write the function and corresponding domain for each section. So definitely have to do this tomorrow. This is 4. I think the one I'm having you do tomorrow is just 2. So it shouldn't be quite as involved. So if you can do one with 4, you can hopefully do one tomorrow with 2. First thing we're going to do. So if I go to my first line, so these are all colored comboed here. So if you go to that blue line, to write the equation of any line, you definitely need your slope. So if I'm going to ask you what your slope is, we go from this point to this point to this point to this point. We're going down 1, right 1, down 1, right 1, down 1, right 1. So we would say that that slope is a -1. The point, if we know the y-intercept, that's the point that you want to use. So in this case, notice how this blue line actually does cross the y-axis nicely. So let's use that point. That is the point 0, 5. The reason that is nice is because if we know the y-intercept, when I go to now actually write the function, which is ultimately our goal, so if I go to write the first subfunction right here, because we know the y-intercept, we're going to be able to use the form that we're most familiar with, the y equals mx plus b form, because we now know that our slope is a -1. So in the spot where the m goes, you're going to put the -1 there. So let me do that. And because we know the y-intercept here, our line actually crosses the y-axis at 5, we can just jump right to slope-intercept form. This is the equation for number 1, -1x plus 5. Whenever you do a piecewise function, though, remember there's 2 different things. Not only do we need our function, we also need the domain in which this is defined. So if you look at your blue line, so let's come back up to the blue line. Here is the start of the blue line. Work your way down to the x-axis. That blue line starts at the x coordinate of a -2. So we start our domain at a -2. And then we want all the x's to the right of that. So we write that like this. And then that blue line ends right here. And that is the x coordinate of 1. So then we want to be less than or equal to 1. So that's the first subfunction and its domain. Okay. We then go to our green line. So the green line has 2 points, this point to this point. So our slope, first and foremost, is up 1, up 2, and then right 1. So we're going to go up 2, right 1. So that tells me my slope is 2. Notice how this one doesn't cross the y-axis. So you now need to either pick this point or this point. So you can pick either one. I'm going to make this one my point. So I'm going to make this big and fat right here. I'm going to pick 1, 4. So this is the point, 1, 4. I'm going to use that point. When we now go to write the equation of this line, since we don't know our y-intercept, remember how this is what was, you did this a little bit last year, but the first time we did it this year was last week, the whole little point slope version. The m always stands for slope. So we already know what that slope is. It's the 2. So we're going to slap a 2 in right there. And that works. Let's try again. All right. So get rid of your slope. We know our slope is going to be a2. Then we need an x-coordinate. The x-coordinate of the point that I picked is that 1 right there. So you're going to put a 1 for that spot. And then the y-coordinate of that point is a 4. So where we see the y down here, you're going to do a +4. Domain, look at your green line. The green line starts at this point right here. And that point has an x-coordinate of 1 that we've already identified. So this one will start at 1. And then we want all x's that are on the far right side of 1. And then that stops, the green line stops at 2. So we look at where that one stops. So this one would be less than or equal to 2. Okay. All right, pink line. So now let's go to our third line. So here's a point, here's a point, here's a point. So let's count that slope. We're going to go down 2, right 1, down 2, right 1. So for the red line, down 2, right 1, down 2, right 1 means my slope is a -2/1. So -2. Then we need to pick a point. I am going to pick this point right here. That's on the red line. So that is the point 2, 6. So with that, real quick, let's see if we can now do the function and write your domain. Right, so take a minute and do that real quick. If you've got it. Or if you have paper, write it down, see if we can do this for tomorrow. And then make sure not only do you write the equation, but you write the domain on the right-hand side. Okay. Okay, so let's do our domain first. I think that's hopefully the nice one. We just want the red line. So if I look at my red line up here, the red line starts right here at the x-coordinate of 2. You follow my little marker here. So from that point, we start at 2. And then we want x's to be greater than that 2. And then the red line stops at this point, and the x-coordinate of that point would have been a 4. So we want to be between 2 and 4. The red line doesn't have a y-intercept. It doesn't cross the y-axis nicely. So what that would then mean is we probably want to go with the point slope version. Our slope, if you remember, we already, up here, I cross it out, but we had found that to be a -2. So in this spot right here, you're going to throw in your -2. You could use different points. I wrote down the point 2, 6. Why does it keep doing that? So I wrote down the point 2, 6. So that just means I'm going to take this 2, plug it in for my x. Just a little bit. So there goes the x, and I'm going to replace that with a 2. And then the 6 is my y-coordinate, so that's going to go right here. And that's our equation. Okay. Any questions on that? Any issues with that? All right. Then without any work with us, do all this yourself. So I'll give you another minute. Pick a point you want to use for that fourth line. Figure out the slope of that fourth line, the orange line. Once you have those two things, whatever point you pick, whatever you find the slope to be, go ahead and write the function and then write your domain. Okay, so you have the orange line, point, the slope, and then write the equation in the domain. Let's see what we got here. We'll start slow here. Brooke, what point did you pick, Brooke? All right, good. Brooke picked this point right here. So for Brooke, don't change your equation. Don't change your point. I'd rather you leave your point just to kind of show that you can pick any point you want. She picked 6,3. We could have used this point right here. I'm going to guess a lot of you picked this point. We could have used this point. We could have used this point. So there's really 4 different points you could have written right here. Now, we should all get the same slope. So if we do these all correctly, we should all get the same slope. So, Kaylin, what do you think for the slope of the orange line? Good. She got 1/2. So that's good. We're going up 1, right 2, up 1, right 2, up 1, right 2. So point and then our slope. So then from there, again, I would suggest doing this one since we don't know our y-intercept. We know what our slope is. So that's going to be, what did we say, 1/2. Now, this might look a little different for yours. What I'm doing is I'm going to take the x-coordinate from Brooke's point. So Brooke picked 6,3. So don't change yours. Just leave your point. But I'm going to have a 6. And then 3 is Brooke's y-coordinate. So I'm going to get rid of this y. And I'm going to replace that with the 3. We'll come back to that. So have whatever your equation is, just leave it. When I go to do my domain, the orange one starts right here at 4. And then we want all x's to the right of 4. And then at the same time, the orange one, I can't see where it stops. Okay, should have stopped right here at 10. All right, so now what a lot of you are probably thinking, because I doubt every single one of you, if you tried this, legitimately picked 6 and 3. You may have picked a different point. So right now, this might be looking a little bit different between you and what we have here. So what I want you to do real quick, because ultimately, by the time we get to the test, I'm only going to have you do one of these tomorrow, so it's not a huge deal. Just get the right equation to start. If I now simplify this, though, all of our equations should look the same. So if I do 1/2 times x, that's a 1/2 x. If I do 1/2 of 6, that's a -3 plus 3. So do the same thing to yours. Distribute the 1/2. If I now combine like terms here, if you simplify all of yours at home, every single one of us would end up with the slope-intercept version of just 1/2 x. We would all get the exact same equation, regardless of what point we pick. Now, I'm not asking you to do that tomorrow. I'd rather you just make sure we know a point slope and we know the point slope version. But long term, when we get to our test, that's what we're going to want to do is clean all those up. Okay? Any questions on any of those? Can we do this tomorrow? Okay. Good. Hopefully we can. All right, then real quick. This I think we're reasonably good at. So if I go to number 2, if I ask you to do f of -1, you could really do it 2 different ways. So if I want f of -1, this is just saying let x be a -1. And when x is a -1, what y value do I get? One way to do it is your graph. So if we pull back our graph here, go to where let me clean this up a little bit. I got a lot of stuff going on. Go to where the x value is a -1 and figure out what's the y coordinate of our graph. So the x value of a -1 is right here. So as we go up to our graph when x is a -1, notice how we get a y value of 6. So f of -1 is 6. That's if you have your graph. However, let's say you don't have your graph and we only have our function. Let me clean this up a little bit too. Think about where this x value of -1 fits. Doesn't -1 fit in this interval right here? So we could just let this x become a -1. Plug a -1 into that. So that's what I'm going to do. I'm going to take this -1. I'm going to replace the x with the -1 I'm telling you to put it in, and then add 5. So isn't a -1 times a -1 a +1 plus 5? That would also give you a 6. So you can either use the graph if you have it, or you can use your function. So now number 3, do whichever way you prefer. So if you want to look at the graph, find f of 4. If you want to use the function, figure out where 4 is defined, plug it in. Either way, we should all get the same thing. So find f of 4. Oh, you probably need the graph. Let's use the graph first, since some of you don't have this at home. So let's use the graph. Find f of 4 using the graph. You use the graph, there's no work. As long as the graph is provided, we can just look at it. So what this question was asking, I'll pull it up real quick. F of 4 means when x is 4. So if we look at our graph, here is when x is a 4. Go to your graph, and on that graph at this point, when x is a 4, we get a y value of 2. Okay, so f of 4 would be 2. The other option, when x is 4, that's defined right here. So we could just plug a 4 in for this part of that equation. I guarantee you when you evaluate it, it's going to spit out the same exact answer of 2. Okay? All right. Let's do one more of those. F of 10. Let's do f of 10 with the function. I'm not going to show you the graph. If you have the graph, don't use the graph. So if I give you f of 10 right now, because tomorrow you won't have both. You may just have the function, so let's make sure we know how to do it with the function. So if I ask you to find f of 10, identify which one you need to plug it into, and then see what that evaluates to be. All right, so if I now ask you for f of 10, if I have these 1, 2, 3, 4 different sub-functions, all right, Mason, where is 10 defined at? The first, second, third, or fourth? Good, so it's in the fourth one, so here's where the 10 would get defined. So we're replacing this x right here with a 10. So we would get 1/2, 10 minus a 6, and then add a 3. Whatever that evaluates to be is f of 10. So this would just become half of 4. So half of 4 is 2. 2 plus 3 should be 5. So we hopefully got f of 10 to be a 5. All right. Okay, we'll skip 5. Those were actually reasonably good at. 6 and 7 are the ones that, as we've given you these right before winter break and then after we got back here, has been a little iffier. So number 6 now is the opposite of what we just got done doing. What number 6 is asking you is, if y equals 7, what's your x coordinate? So now f of x is the same thing as y. So just understand y and f of x mean the exact same thing. So go to your graph, and we want to figure out where does y equal 7. So if I come up here to my graph, here's your y-axis. So if we now go, here's the y value of 1, 2, 3, 4, 5, 6. I guess I already had that one marked. Here's that. And then here is the y value of 7. So if we go in this direction, does our graph ever have a y value of 7 if we go to the right? Right? Never touches it, right? But if I go in this direction, I will eventually hit this point right here. This is the point that has a y value of 7. And what we're looking for is what x coordinate do we have at that point. And if we scroll on down, the x coordinate there is this -2. All right, so we would say for that one, x is a -2. So then last one, before we finally turn the page on this, do this one. I'll pull up the graph here in a minute. We are looking for when the graph has a y value of 2. All right, so when is the y value 2? So there's your graph. So tell me the x coordinate where the y value is 2. In a way, I already have it marked. Second guy, I'll go to you though in a minute. Alright, so Gael, what do you think, Gael? When y is 2, what x value do you get?
You get 4.
Good. So we should get 4 there. Here's again our y-axis, right? Up and down this axis. Here's when that y value is 2 right here. And so the only time we touch our graph is at this point, and the x-coordinate there is 4. Okay? All right. Good. All that's going to be on there tomorrow. Hopefully we can do all of that on that little quiz. All right, next page. So there's just 2 pages. The other thing I'm going to have you do tomorrow, I'm going to give you a graph, and I'm going to have you write the function for it, just like we did before, but it's also going to be a word problem. So it says a gift wrap service in the mall charges $3 for the first 2 packages they wrap. So let's make sure we understand how that ties into our graph. Make it a little smaller so we can see it all at once. So if you look at your graph, for 1 package or 2 packages, notice how the price is always at $3. So that's what that first sentence is saying. Second, as we continue that first sentence, after that, the fee is $2 per package with a maximum number of packages per customer. So if you're going to get 3 packages, so now if we come here to 3, we have to pay an additional $2. So that's why this one is up here at $5. If I go to 4 packages, I'm here, I'm going to have to pay $7, so on and so forth. The maximum number of packages per customer is 10, so that's the most that we can have gift wrapped. So this now asks, write a piecewise function for the cost of wrapping X packages. So we now want to write a function for this equation just like we did before. Now, the thing we didn't do last question is to write the equation. Remember how this is a horizontal line? I'm going to write this here. You have notes in front of you tomorrow when you take this. There's no reason to forget this, to not have this correct. We talked about how the equation of a horizontal line is always y equals some number. Always. So all you're going to have in this first piece of the function is a number. So look at that horizontal line. If I have 1 present wrapped, don't I pay $3? If I have 2 presents wrapped, don't I pay $3? So isn't the amount of money I always pay going to be $3? So that's all you are putting, y equals 3. We still need our domain, so don't forget that. So if we look, this line here that I have highlighted starts down here at 0, and it stops at 2. So we're going to go all x values to the right of 0, but to the left of 2. The next line, now we need to go back to what we did in the previous page. We need to figure out what's our slope and what's the point. Since we don't have a y-intercept here, we're going to go ahead with the point slope version. Let's find our slope. So from this point, I'm going to go up. There's different routes you could take. If I count each tick mark, I go up 1, 2, 3, 4, right 2. So that would be 4 over 2. If I actually go by dollars, notice how I'm going from $3 to $5, so $2. And then I'm really moving from 2 packages to 3 packages. So you could do 2 over a 1. Either way, these both will tell you that your slope is 2. And then I'm going to use this point right here. So that's the point 3, 5. By using that point, my x coordinate here is going to be 3. My y coordinate at that point is 5. That's our equation. Notice where that line starts. That line starts at 2. And then we want all x's between 2. And then it looks like this goes on forever, but I'm going to circle it. So as you see me circling here, it says the maximum number of packages is 10. So that's the most packages that we could have gift wrapped. So that's telling us to stop that at 10. The next two, I don't think we need to talk about it before I have you try it. Do 8B and 8C. So how much does it cost for 3 packages? How much would it cost for 7 packages? One of them should be very easy. The other one you might have to do just a little bit of work or thinking. All right, 8B should be the nice one. Doesn't take a lot of thought. We actually have it written down, right? Like if I go 3 packages, that's what the x-axis stands for. So if I have 3 packages, we've already got it labeled. You're going to be paying $5. If I want 7 packages, so understand the tick marks here, this would be 7. I can't really see the graph here. So you could kind of do it in your head. Just know you're going to increase by $2 for every package, and you can just kind of count that way until you get to your 7th package. Or like we talked about on the front page, if I want 7 packages, doesn't 7 fit in this window right here? So we could just plug in a 7 for this X, and then whatever that spits out should be our final answer. All right, so if you do that, hopefully you got $13, however you did it. Okay. All right, in our last 3.5 minutes, what I would like to do for certain, write the first equation in domain for this first part in number 9A. So now it's a babysitter charging $9 an hour for 2 kids. If you add kids, she's going to charge you more money, $3 per hour. Write the equation for that first one in particular, just to make sure we get 2 of these done today. Okay. Okay, I wrote it again. A horizontal line will always have the equation of y equals some number. So notice how this is a horizontal line. Now our y coordinate in that line is always $9. And that's what this is saying. For the first 2 hours, they're going to charge you $9. There's no change in price for 1 kid or 2 kids. So we can just do y equals 9, comma, and then that would be for 0 to 2. Okay. For the next one, since we do have a couple minutes left, just to make sure we can do one of these, this one is going to go from 2. And then they said a maximum number of kids. Oh, wait, I miscounted. Never mind. We're done. If you have any questions, see me in the morning. I thought we were getting out at 20. See me in the morning before class. I'll hop on in our intervention. Okay, we'll see you guys. Have a good day. Shoot. Has it always been 11:19? Why was I thinking 11:20? Is it? Maybe. See you, Ahmad. Good seeing you guys. Have a good day. No, I gotta stop recording. I hope it recorded because it says 1 right here. It never stopped counting down. Yeah.